Blackouts in California, energy crisis in freezing Texas, natural gas prices going crazy in Europe. While climate change is collapsing our energy system, we keep searching for solutions. Wind turbines don't work when the wind stops. Solar panels don't work when the sun sets or snow falls. Battery technology is still inadequate. Nuclear energy is politically impossible. But wait a minute. Look at those oceans. They never stop. Day and night, every season, constantly in motion. What if I told you the oceans could generate energy to meet 20% of the world's electricity needs? 24 hours, 365 days, never stopping. Why doesn't this technology exist? Why have you never heard of it? And most importantly, why did dozens of companies go bankrupt trying to develop this technology? There's something wrong with this story. And if we solve this inconsistency, we could end our energy crisis. Wave energy is completely different from solar and wind. It extracts energy from the constant motion of water. This energy comes from Earth's rotation and temperature differences created by the sun. According to the IPCC, the global potential is 30,000 terawatt hours per year. That's nearly twice the world's total electricity consumption. America's coastlines alone could generate 1,400 terawatt hours of wave energy per year, more than a third of U.S. electricity usage. And here's the crazy part. 1 square meter of solar panel produces 200 watts. Offshore wind turbines produce a few watts per square meter because of spacing. But the same area in a high-energy wave field can produce 30 to 70 kilowatts. Even better, oceans never stop. 24/7 energy. Stronger waves in winter because temperature differences increase exactly when solar energy is weakest. So where is this super technology? The truth is, wave energy currently produces almost nothing. Zero. Despite being so promising, the technology hasn't developed. In the early 2000s, dozens of wave energy companies made headlines. Then they went bankrupt one by one. British company Pelamis was founded in 1998. In 2008, it built the first grid-connected wave farm in Portugal. It generated 750 kilowatts. A few months later, it had to be towed to shore due to technical problems. While being repaired, a major investor went bankrupt. The units were never redeployed. Australian company Ocean Links deployed a large device on Australia's southern coast. It sank. The company went bankrupt shortly after. Canadian Finavira Renewables abandoned its project after the prototype sank in a 2007 storm. Scottish Aquamarine Power was founded in 2005. It couldn't get enough funding to convert its demo into a working product. It went bankrupt in 2015. And so dozens of startups burned through funding and quietly disappeared. What was the main challenge? In short, the sea is rough, and these devices simply couldn't survive the harsh environment long enough to justify the investment. The ocean works 24/7, but also tries to destroy everything 24/7. Salt water causes corrosion. Waves create metal fatigue. Storms tear everything apart. First-generation companies underestimated the engineering problem. Surviving at sea is as difficult as ships, and ships went through thousands of years of development. Oil platforms could survive, but they were billion-dollar structures. Wave energy devices had to be much cheaper to be competitive. Maintenance costs went crazy. Repairing something at sea is 10 times more expensive than repairing it on shore. By the mid-2000s, wave energy was basically dead. No one wanted to invest more money. But the new generation of companies learned from this. Their machines are designed to survive. Some shut down in storms, some submerge, some put sensitive parts on shore. Earlier this year, Swedish company Eco Wave Power connected a small wave unit to the grid in Los Angeles, the first grid-connected wave energy system in the United States. At the same time, another Swedish company, Core Power Ocean, secured 40 million euros from the EU for a 10-megawatt wave power project on the Portuguese coast. The U.S. government completed PacWave, its first grid-connected wave energy test site in Oregon. More pilot projects are underway in Taiwan, South Korea, and Ireland. Is the technology finally maturing? There are several different wave energy technologies. The simplest are point absorbers that float on water. They move up and down with waves and convert that motion into electricity. Eco-wave power works like this. Then there are attenuators, which are long-jointed structures that flex as waves pass along them. Overtopping devices collect water that comes in from above, then drives a turbine as it flows back out. Danish company Wave Dragon works with this. Some work underwater. They're mounted on the seabed and swing back and forth with wave motion. Which technology will win isn't clear yet. Each has advantages, but they all have the same enemy, the ocean's ruthlessness. So what's changed? Two things. First, interest in renewable energy has exploded. It's now much easier for startups to find funding. Climate crisis requires urgent action. Governments and investors are ready to try every option. Second, we're starting to see the limits of solar and wind. Intermittent energy is a real problem. Storage is still too expensive. Texas snowstorm, California fires, European energy crisis all showed how fragile energy security is. Wave energy can't replace solar and wind, but it can complement them. And technology has finally reached a critical point on the maturity curve. Waves have hidden advantages over wind and solar. Waves are predictable. You can know how much energy you'll generate 5 days in advance. Winter waves are strongest in northern latitudes, exactly when solar energy is weakest. Nearshore installation is possible, much cheaper connection than offshore wind turbines. No visual pollution. Devices are at or below water level. If designed correctly, it can be compatible with marine ecosystems. It can even create artificial reef effects. And don't forget that crazy energy density, 30 to 70 kilowatts potential per square meter. Wave energy isn't a magic solution that will save the world, but it's promising for countries with coastlines. 40% of the world's population lives within 100 kilometers of a coast. Wave energy could be a game changer for these countries. Scotland, Ireland, Portugal, Chile, Australia, California all have tremendous wave potential. Of course, there are still challenges like grid integration, storage, costs. Current costs are still too high, but every new technology starts this way. If the learning curve kicks in, costs could drop rapidly. If this succeeds, we'll have to explain to our children why we waited 1,000 years to notice that oceans move. Humans have been using water power for thousands of years. Mills, dams, river energy. But we never looked at the constantly moving oceans, as if they were invisible despite being there. Solar and wind energy developed in 50 years. Why was wave energy so late? Maybe because the engineering is really hard. The marine environment is harsher than anything else. Maybe because investment risk was too high. Solar seemed like a safer investment, but now the technology seems ready. To be honest, I'm not 100% sure wave energy will succeed. We've seen many promised technologies. Fusion energy has been 20 years away for 50 years. The hydrogen economy was always coming soon. Ocean engineering is really difficult. Maybe some physical limits can't be overcome. But this time, there's hope. The new generation of companies seems smarter. They're designing for survival. Market conditions are also favorable. Energy crisis, climate change pressure, government support. This development is worth watching. Wave energy might not completely solve our energy problem, but it could be an important part of the energy portfolio. Solar during the day, wind when it blows, waves constantly. Together they could provide 24/7 clean energy. For coastal countries, it could mean energy independence. Technology finally seems ready. The next 10 years will be critical. Investment and policy support are needed. But there's hope, and the oceans are there, constantly moving, as they have for billions of years. Maybe it's finally time to listen to them. Write what you think in the comments. Are you optimistic about the future of wave energy?